All right, let's talk about container images. We're going to dive into how we can go from the chaotic, kind of messy world of containers to a place of real confidence and security. This is all about finding a better, safer way to build our applications right from the very beginning. So let's just start with a question. And be honest, it's one that probably keeps a lot of us developers up at night. When you pull a base image from a public registry, are you 100% sure what's inside? Every single package, every dependency, all the potential vulnerabilities that might be hiding in there? Yeah, it's a pretty common anxiety, and for a really good reason.
So to get to the bottom of this, here's our game plan. We're going to start by really defining the problem itself. Then, we'll look at building on a more secure foundation. We'll peek inside the security toolkit, see how to build a real chain of trust, and of course, see how to put all this to use. And finally, we'll look ahead at the future of secure builds.
Okay, first things first, let's really pin down what we're up against. The convenience of public container registries is amazing, but it definitely comes with a hidden and often pretty steep cost. Think of it like this. The public container ecosystem can feel a bit like the Wild West of software. A lot of the most popular base images are basically black boxes. We build our most critical applications right on top of them, but we have almost no idea what's really inside. You could be looking at outdated libraries, a bunch of tools you don't even need, and even worse, some really critical security holes. So, how in the world do we bring some order to all this chaos? Well, the answer really is to start building from a foundation that you can actually trust. And that's exactly what we're going to get into now. And that brings us to this really cool open source project called CyberGavin/Container Images. What it does is provide a whole set of standardized, secure, and minimal base images. The entire point is to give you a starting point that isn't some mystery box, but a well-documented, controlled foundation for whatever you're building. It just takes all the guesswork out of the equation. Now, what's really great here is that you have choices. It's not a one-size-fits-all solution. If you need a super tiny, fast image for your microservices, Alpine is perfect. If you're working in AWS, well, Amazon Linux is optimized for that. For big enterprise apps that need that RHEL compatibility, you've got Alma Linux. And then there's Wolfie, which is really interesting. It was designed from the ground up for a zero vulnerability approach, so you can actually pick the right tool for the job. And the best part is the consistency you get. No matter which of those images you pick, you get this super predictable environment. You've got essential tools like curl and JQ already installed, a standard non-root app user is all set up, and there are even scripts in place to stop you from accidentally upgrading packages and introducing new bugs or vulnerabilities. Okay, so we've got a solid foundation, but what specifically makes these images more secure than your average public image? Let's pop the hood and take a look. And when you put them side by side, the difference is just night and day, right? Traditional images, they often default to running as the all-powerful root user, they come bloated with tools you don't need, and you never really know what you're going to get. These hardened images flip that completely. They run as a non-root app user by default, which is a huge security win. They're minimal, so the attack surface is tiny, and they're intentionally static, so what you test is exactly what you deploy. And this right here is absolutely crucial. Security isn't just a feature, it's a gatekeeper. Every single build gets scanned by two different industry-standard tools, Trivy and Gripe, and if either one finds a critical or high-severity vulnerability, the build just fails, period. The image never even gets published. This is all automated, it's mandatory, and it's totally non-negotiable. Now, a secure image is great, but in today's world, that's not quite enough. You also need to be able to prove how it was built and verify its contents. This is where we build a verifiable chain of trust. So first up is something called an SBOM, or a software bill of materials. Honestly, the best way to think about it is just an ingredients list for your software. It's a file that a computer can read that lists every single component, every library, every dependency inside that container. No more mystery meat. Next up is provenance. So if the SBOM is the ingredients list, think of provenance as the image's verifiable birth certificate. It records exactly how the image was built, what source code went into it, which build system created it. It's a tamper-proof history of where that artifact came from. So how does all this magic happen? It's all part of this fully automated build pipeline. You can almost think of it like a robotic security factory. It kicks off by finding and checking the Docker files for best practices. Then it builds and tests everything, and then runs those critical security scans. Only if it passes everything does it get published. And at that point, it attaches that crucial SBOM and provenance data, and for the grand finale, it cryptographically signs the whole package.
Okay, this all sounds great in theory, but how easy is it to actually use these things and, verify them in your own projects? Let's get practical. So using these in your own Docker file is actually super straightforward. You just start from the trusted base. But notice the pattern here. You temporarily switch to root so you can install your packages, but then, and this is the most important part, you immediately drop back to the app user before you run your application. This one simple habit dramatically improves your security.
There's that classic phrase, and it is pretty much the guiding principle for all of modern software supply chain security. You shouldn't have to just blindly trust that an image is what it says it is. You should be able to prove it. And you can prove it with just a single command. The project uses a tool called cosign for keyless signing, and it basically acts like a digital tamper-proof seal on the container. By running cosign verify, you can cryptographically confirm that the image you just pulled actually came from this secure build process and wasn't messed with on its way to you. Okay, let's zoom out for a minute and just think about the bigger picture. What does all of this really mean for the future of how we build software? And here's the key takeaway. This project is way more than just a collection of useful images. It's a practical, open-source blueprint for having a secure by default mindset. It shows you exactly how to bake modern supply chain security right into a completely automated workflow, making the secure path the easy path, not the hard one. So if you're going to remember anything from all this, what are the core principles? Well, it really boils down to a simple cycle. First, start with a minimal trusted foundation. Second, automate your security checks and make them mandatory. Third, generate the evidence, the SBOMs and the provenance that proves your software is secure. And finally, sign everything to guarantee its integrity and always, always verify those signatures before you use anything. And that leaves us with one final thought. You probably spend countless hours securing your own application code, right? But if the foundation you're building everything on top of is a black box full of vulnerabilities, how secure is it really? It's time we all started building on solid ground.